So we're looking at the slope of the tangent line. We were just discussing what that tangent line would look like if we were on some function f of x. And so again, if we have some function f of x, maybe a parabola this time, and we were looking at some value x equals a, it would be the slope of the tangent line. The tangent line would look like this there. Maybe not so much like that. Okay, so headlights would be facing kind of this direction. So this would be the tangent line at x equals a. At x equals a. And if we chose some other value, let's say b, if we were looking at, if we were driving and it was nighttime and our headlights were facing, and we're going left to right, would be facing down this way. And so this would look like the tangent line. At x equals b. So the slope of the tangent line on the graph y equals f of x at a point a, so when x is a, our y value, again, we could write it as f of a, is the line through the point having the slope the limit as h approaches 0, f of a plus h minus f of a all over h. Okay, so we have to put on a little stipulation here, provided that the limit exists. So provided the limit exists. All right. If the limit doesn't exist, then there's no tangent line at that point. So if the limit doesn't exist, then there's no tangent line at that point. And we'll talk about what could be happening if the limit doesn't exist, but not right at this second. Okay, so let's look at one example of finding the equation of the tangent line at a particular value. This looks like a great example. So it says for each function, find A, the equation of the secant line through 2 points where x has the given values, and B, the equation of the tangent line at x when x has the first value. So let's say you had some function f of x. You were given that this was equal to 6 minus x squared. And we wanted to look at first the equation of the secant line when x equals -1 to x equals 3. So find the equation of the secant line. Okay, so I just kind of want to recall real quick. To find an equation of a line, you need 2 things. And if you don't have those 2 things, you can find those 2 things. So to find an equation of a line, and I call it just EQ for short, we need a point and the slope. And once you have a point and you have the slope, then we can find the equation of the line. And there was a couple of methods that you can do to find the equation of the line. Recall you had your point slope formula. So if m was equal to the slope, and let's say your point, we called them x sub 1, y sub 1 on the line, then the equation of the line is y is equal to, or y minus y sub 1 is equal to your slope m times the whole quantity, so parentheses x minus x sub 1. So once you figured out what the slope is, you'd plug that value in for m. Once you had a point, you go back in and plug in those values for x sub 1 and y sub 1. So that was one way to find the equation of a line. I tend to use a different method, and I use your slope-intercept form. So slope-intercept form of a line. We have y is equal to your slope m times x plus b. So if we know our slope when we're doing it this way, and we know what a point is, first what you would do is plug in your point and your slope. Into that equation, y equals mx plus b. If you do that, you'll have just a variable of b left, and then you're going to solve for b. So once you figure out what this value b is, then you're going to go back in and you're going to plug in b and m into the point slope formula, y equals mx plus b. So if you plug in your slope value here and your y-intercept, your b value here, you would have that equation of the line. The slope-intercept form, to me, it's just easier to see what the graph is going to look like, because you know what your y-intercept is and you know what your slope is. So it's kind of a review of finding equations of a line. And so Let's do that. Let's find the equation of this secant line. And so we have we have two x values. And in order to find the equation of the line, we need a point and we need a slope. And so we need our points. So let's find our points. So let's find the y value when x equals -1. Well, the way to write that is f of parentheses -1. So you're going to go back in, and wherever you see an x, an f of x, we're going to replace it with -1. So let's just first put a parentheses wherever we see the x and then go in and rewrite it. So 6 minus parentheses, because I see an x there, and then square it. So if I plug in -1 and I simplify, order of operations, 6 minus. So first we're going to square the -1. -1 times -1 is +1. And then 6 minus 1, we get 5. So I know we have a point at -1, 5. Okay, so I have a point, but I also need the slope. And I don't have the slope, but I know I can find the slope because we actually have 2 points. And so let's find out and find y when x is 3. And so we're going to go in and plug in 3 wherever we see an x, an f of x. And so we have 6 minus, I see an x, so parentheses, square that parentheses, and write 3 inside the parentheses. Order of operations, we have 6 minus 3 squared is 9. 6 minus 9 is -3. So we also have a point at 3, -3. So we found 2 points. Now we want to find the slope that joins those 2 points. So we're going to find the slope of the line joining these 2 points. Okay, so we can do that. We know that m is equal to the change in our y value. So let's start with 5 minus the other y value, -3, all over the change in our x value. I started with this top above point above, so I need the x values to start at -1 minus this x value of 3. So let's simplify that. So we get m is equal to 5 minus -3, 5 plus 3, all over -1 minus 3, which is -4. Well, 5 plus 3 is 8, divided by -4. This gives us -2. So we have a slope, which is -2. We have a point, so it doesn't matter which point you choose. Let's choose, how about the first one, -1, 5. So using this, we want to find the equation of the line. So I'm going to use my y equals mx plus b. I'm going to plug in my x value, which is -1. I'm going to plug in my y value. So y in here is 5 is equal to 5 equals our slope. Our m value in here is -2 plus b. Okay, so plugging in our point, plugging in our slope, we can now figure out what that b value is, our y-intercept. So we have 5 is equal to -2 times -1 is +2 plus b. We're solving for b, so we need to isolate this. It's a linear equation, so we isolate that, subtract 2 on both sides. We get b is equal to 3. So knowing that our b value is 3 and our slope is -2, we're going to go back into our equation, y equals mx plus b. We're going to plug in what our slope is, and we're going to plug in what our y-intercept is, and we'll have our equation of our line. So y is equal to our slope, -2 times x, plus b, and b was 3. So this is the equation of the secant line. That joined those 2 points. So I just kind of want to take a second. Let's go to Desmos. Let's graph this equation, f of x. And let's graph this equation of the secant line. And then we'll take a break. Actually, maybe we won't do that because of my computer. Let's see, I'll try. Okay, so I just went to desmos.com, pulled up the graphing feature and plugged in the 2 equations we had. So we started with a function 6 minus x squared, and then we found the equation of the line, the -2x plus 3. If you look at this, you'll see that we have a point here, which we found when x was -1, y was 5. And then we have that point down here when x was 3, y was -3. And then we found the line that went through both of those 2 points. So that is the average rate of change we found to be -2 between those 2 points, but the equation of the line, which we call this the secant line, is -2x plus 3.